Okay. Tabular integration. Now, the math that we are learning right now in calculus is mostly more than 200 years old. Right? It was invented a long time ago. The math that's invented right now is impossible to read even for me. It's really specialized. So it's a bit surprising to find out that in the 80s, a Russian mathematician, I forgot his name, he actually came up with a different way to do the integration by parts. He invented this tabular integration. In math world, 1980 is like yesterday. It's like very recent. So although this is invented in the 1980s, it's still making its ways to the textbooks. So some of the old textbooks doesn't even mention tabular integration, but it's so much easier that this is going to be our preferred way of doing integration by parts. Now, before I start explaining what this is, I want to say that this is just a repackaging of the integration by parts in a nicer way so that you have less to write and it's faster. And therefore, anything you can solve using integration by parts, you can solve using tabular integration. Anything you can solve using tabular integration, you can solve by integration by parts. It's just less confusing. And if you have worked with integration by parts so far, you kind of understand how confusing it is, right? All kinds of constants come up, the plus and minus, they change. So it becomes something that's really easy to make mistakes on. That's why learning this tabular integration will be really important. All right. So to make my point, I want to start with something that we've done earlier. We did integration of x squared plus 4 e to 3x. And since we already have the answer done, I think the answer was what? 1 over 27 e to 3x, 9x squared minus 6x plus 38 plus c, right? That was the answer. So that was our previous answer by doing integration by parts twice. So let's try to get the same answer by using this thing called tabular. All right, tabular just means using the table. And you always want to put the correct ones in the, you always want to name the columns in the correct way, because if you switch the order, then it doesn't work. You have to always remember that the first column is the plus minus, second column is derivative, and the third column is integral. So always write that in that order. Never mix them up. And the same idea of Lie applies here, because it's the same thing. You have to integrate one and differentiate the other. What should we be integrating? Lie. We have an algebraic function times exponential, so we should really be integrating the exponential. So whatever appears on the right side of the right side of the Lie, you put it in the you put it in the integration column, e to 3x. The one that appears on the left side, you put it on here. Now, at least for the case when you get a polynomial in the D column, you want to fill in this column by differentiating over and over again. Okay, so if you differentiate x squared plus 4, you get 2x. You differentiate 2x, you get 2. Differentiate 2, you get 0. When you hit 0, you stop. Okay, for the integral column, you keep integrating. What's the integral of e to the 3x? 1/3 e to the 3x. Remember this 1/3 created by this 3, right? If this was e to the 4x, this should be 1/4 e to the 4x, right? Okay, you integrate this again, what do you get? 1/9, because it's another 1/3. 1/3 times 1/3 is 1/9. Integrate this again, you get 1 over 27 e to the 3x. And this column will alternate plus, minus, plus, minus. Now, if you recall how we calculated this answer from using the classical integration by parts, you will realize that all the calculations that we've done over there appears here. They all appear in the other calculation as well. So what that means is that everything in here will be like the building blocks to compose the final answer for that. You just have to know how to put them together. And the way you put them together is like you want to use some imagination. Let's say you have war between two countries. Like here's a big, powerful country, and here's a small island country. Okay? The powerful country like USA, we have lots and lots of missiles, and we like to use them, right? And it's really nice if you try this with some sound effect. Don't do that during the exam because it's going to distract other people. So I'm just going to do it the first time. Okay? So the first missile fires, just like that. Okay? And then when the missile crosses paths, and really the path of the missile goes like this, same level, and it falls down. Okay? That's how the missiles are fired. Okay? Same level falls down, and all this gets multiplied, so you get x squared plus 4 times 1/3 e to the 3x. Okay? And then another, just like that. Okay? And then 1/9 times 2 is 2/9. There's a minus, so it's negative 2/9. X times e to the 3x. And then all right, so the poor island country attacked by this powerful country has lots of people. I'm not sure if I should be recording this. But anyways, they only have one rifle. Okay? That's the only weapon. Okay? So what happens is that the island country retaliates by putting a straight line that way. Rifle shot. Okay? And that last line is treated differently because this time not only you have to multiply them, but you should also integrate it. Now there's a 0 here, so of course 0 times anything is 0, so you're going to get 0 on this side. But you should be integrating this 0. Now what's the antiderivative of 0? No?
1.
No? Any constant, right? Because any constant differentiates to 0, right? So antiderivative of 0 would be c. And now what do you think we should be doing? Just add them up. That's your final answer. Looks really simple, right? So this is, if I write this as 1 over 27, then 9 gets multiplied. So 1 over 27, 9x squared plus 9 times 4 is 36, e to 3x. Minus, I'm going to multiply 3 top and bottom, so it's 6 over 27, x times e to 3x. And that's 2 over 27, e to the 3x plus c. And let's try to factor 1 over 27 e to the 3x. What's left? If I yank out these, those are the ones left, right? So we have 9x squared. There's a 6x, negative 6x. And there's 36 plus 2, right? So you end up with 38, which is exactly this one. So it matches with the previous answer.